Hey, I apologize. I kind of dropped the ball and I forgot. I was going to produce this video a lot earlier, but I got carried away last night grading your tests. So the good news is that your tests are ready to go. You can go ahead and take a look at those scores and let me know if there's anything that seems weird about that. But it is now Sunday morning, and I need to give you guys some more information about how to deal with transformations, up, down, left, right, all that stuff. Technically, I suppose you could possibly be okay given what I went over with you. That must have been on Wednesday, but I wanted to give you a quick view and then just go through a couple problems, make sure you guys are okay with this. So I'm on Desmos right now, so you can take a look at the graph. The graph you're looking at right now is the absolute value of x. That's the green graph that I've got going. And then you can see down here underneath that, I've got y equals that function, f of x, in this case, the absolute value of x minus 1. And so when I turn that graph on, we see that the graph has been moved down by 1 unit. And if you think about it, it makes sense. The function does whatever the function does. In this case, it takes the absolute value. And then whatever that output is, we then subtract 1, that's going to move it down. It's going to decrease the y value. If I make it minus 2, it moves down by 2. If I make it minus 3, it moves down by 3. Pretty evident from the graph. If I make it plus 3, it moves up by 3. And so whatever the function is, take that output, the output of the function, add 3, subtract 3. We've got vertical translations happening. And it doesn't matter what function we're doing. If I make this the square root function, same stuff is happening. Square root of x, the green function, the original function, one of our parent functions is down here. If I take the output of that, whatever f of x is, add 3, moves up 3, add 1, moves up 1, subtract 1, moves down 1, all that same stuff is happening. So we can see outside of the function, f of x, whatever it is, plus moves it up, minus moves it down. The other thing we have to take a look at is what happens when this change, when this transformation is happening inside the function. So instead of f of x, whatever that quantity is, minus 1, I'm going to put that minus 1 inside the function. So now change is happening first. The x value is being affected first, and then it's being sent through this function. And what we see, similar to what we saw last week, was that this minus 1, you might think that would move it to the left by 1, but we see that it moves it to the right by 1. F of x minus 3 moves it to the right by 3. And of course, if I make that plus instead of minus, again, contrary to what you might think, it's moving it to the left by 3 instead of to the right. So plus 3, minus 3, inside the parentheses, inside the function itself, we see that plus moves it left, minus moves it right. And if I have some combination of the two, if I have something happening inside the function, something happening outside the function, x plus 3 on the inside of the function is moving it to the left by 3, and then the plus 2 outside, or you could think of it as after the function, moves it up by 2. So the green graph has been moved left by 3, up by 2 to give us this new graph. And it doesn't matter what our parent function is. I'll switch over to the 1 over x. This one gets a little bit more complicated. I'll maybe turn off the image. We've got the original function. We've got our vertical asymptote, our horizontal asymptotes at the x and y axis. And then when let's maybe just do these things one at a time. If I do f of x plus 3, replacing the x with an x plus 3, it's moving it to the left by 3. And then when I add 2 on the outside, that moves that graph up by 2. So this point, for example, has been moved to the left by 3, up 2. This point right here, the point 1, 1, has been moved to the left by 3 and up 2. And we see that the resulting graph. Now, I'm using function notation here. I'm just really quickly going to show you in terms of the equation might be written that x plus 3 inside the function might look like that. And then the plus 2 outside of the function could be written like that. So we've got our parent function 1 over x, replace the x with an x plus 3. That moves it to the left by 3. That vertical asymptote that was the y-axis is now over here at x equals negative 3. Then that plus 2 outside of the function or after the function that has moved the graph up by 2. Horizontal asymptote that was the x-axis is now a horizontal asymptote up here, y equals 2. And then we'll wrap this up with a couple quick examples. I think I maybe did this one last week, but if I've got a function, in this case the function is the square root function, what will the graphs of f of x plus 2 versus f of x plus 2? And of course, the difference in the parentheses is significant. Here we see the plus 2 is happening outside of the function. Here we see the plus 2 is happening inside the function. And so written in function notation and then just equation notation, y equals f of x plus 2. Well, my function is the square root of x, so the square root of x plus 2. And we just saw that graph is going to be moved up by 2. The plus 2 happening outside the function affects the graph vertically, moves it up by 2. And then that x plus 2 replacing the x inside the function, square root of x versus the square root of x plus 2. We saw that this is going to move the graph to the left by 2. Plus 2 feels like it should move to the right, but we saw that it moves it to the left. So your rules cover all 4 of the cases. We've got the function plus some number, the function minus some number. These graphs are moving up and down. And then inside the function, replace the x with an x plus something, moves to the left. Replace the x with an x minus something, moves it to the right. I'll give you the opportunity to pause the video at this point and get these copied down. And then I'll move on to the general rule, and this will apply to even more complicated things that you'll see in pre-calculus probably next year. Generally speaking, I think about it like this. Stuff that's happening inside the function, before the function is applied, or outside the function after the function is applied. There's a big difference between these two. Stuff that happens inside the function, and I'm going to add on to this. Stuff that's happening inside the function is horizontal. Left, right, how far they move, just based on what the number is. And then outside the function, everything happening outside the function is going to affect the graph vertically. You can even think of this as before and after. Before the function is applied, the x is replaced by an x minus 2. The x is replaced by an x plus 5. Versus outside, where I've got square root, whatever the function is, and plus minus is moving that graph vertically up and down. So homework assignment that you have is going to be a whole bunch of questions that look like this. It should be a quick, easy assignment. Identify the parent function. You've got 6 of them. And you should have that assignment done already if you're watching this video. And then finally, the transformations. What's happening? Up, down, left, right, BA, start. So identify the parent function. In a case like the one that we've got, clearly this is the absolute value function. What's happening? That x plus 2 inside the function is going to move it to the left by 2. And that's all I'm looking for on this assignment. What's the parent function? And then what kind of transformation is happening? So we'll just go through, I think I've got maybe 4 examples to go through quickly. Here, we saw one actually similar to this in the Desmos part of this. My parent function is 1 over x. It's the only thing it could be. It's the only one that has a fraction. I've got 2 different things happening here. I've got that minus 9 that's going to move the graph down by 9. I should just be typing this. And then that x minus 3, that's happening inside my 1 over x function. That's going to move it to the right by 3. You can always get your calculator out, go over to Desmos, plug these in, and actually verify that it works. Obviously, you're not going to want to do that on the test. But, I should say I'm not going to allow you to. That kind of eliminates the point, but there we go. At least while we're getting warmed up, you should use that as way of verifying that you're doing these things right. Here we've got another one that is the absolute value of x. And then I see 2 different things that are happening. Plus 7 inside is going to move it to the left by 7, or the left by 7. And then the plus 7 on the outside moves the graph up by 7. So you can imagine what the absolute value of x function looks like, that big capital letter V. Take that graph, Move the vertex to the left by 7, up by 7. It's still the same shape. We haven't distorted it. It has moved. Here we've got the cube function, y equals x cubed is my parent function. And again, I've got a couple different things happening. This x plus 3 is happening inside the cube function, so that's going to move it to the left by 3. Then I've got 12 plus something and something plus 12 mean the same thing. This graph is moved up by 12. 12 added to it, or it is being added to 12, I suppose, technically, but doesn't matter. We know how addition works. And then finally, this is kind of an interesting one. F of x equals x minus 4. My parent function here is just y equals x. That's just a line. So now the question is, minus 4, is that happening inside the function or is that happening outside the function? And there's a little bit of room for interpretation here. Most of the time there isn't. This plus 7 is inside the absolute value. This plus 7 is outside the absolute value. Pretty easy to see. Not quite as easy here because I don't have those parentheses or grouping symbols, but I've got my 1 over x function. The x is replaced with an x minus 3. That's inside the function. But when I look at something like this, I could think of it as y equals x minus 4, or I could also think of that as the x is replaced by an x minus 4. So we've got two different possibilities here. If I think of it like I've got shown with the current grouping symbols, replace the x with an x minus 4, that would move this graph to the right by 4. If I move those grouping symbols like this, and I say that my function is y equals x, and I'm subtracting 4, that's outside of the function. Well, if that's the case, then the transformation that's happening here is that it's being moved down 4. So which is it? It turns out, for something like this, it doesn't matter. If y equals x looks like this, just a vertical line with, a diagonal line slope of 1, if I take that graph and move it down 4, I get the graph that's over here on the left. Oh, did I say? Oh, I did get it right. And if I move that graph to the right by 4, we get a graph that looks like this. Well, guess what? It's the same graph. It doesn't matter. That's not always going to be the case. In fact, it almost never is the case. But for something like just y equals x, well, different transformations could end up looking the same. I could also say that this graph is moved down by 2 and then to the right by 2. And it'll end up getting that same graph. It'll look the same as both of these. So there is the idea. We'll move on from here. If there's questions, I'll certainly take them on Monday. Again, I apologize for not getting this video up sooner. I guess I just kind of lost track of the order of operations this weekend. I should have gotten this video done before I graded the tests. But as I said, the tests are up and ready to go. Good luck with this. I will see you on Monday. Bye-bye.